If I could ask you an unplanned question, you had mentioned freeze drying earlier. Freeze drying and nitrogen blowdown can be used for sample concentration. I was
Mhm.
hoping you could discuss some of the differences where you would use one approach over the other.
Yeah, so freeze drying, it's very useful for large volumes also. I think it gives you the additional benefit of it's obviously very energy intensive and it's not like everybody has, especially there's different types of freeze drying. Freeze drying at the commercial scale, a lot of people use for freeze drying foods, and those don't withstand such a slower or a lower temperature gradient. But for research purposes, whenever we use a freeze dryer, it allows us to get rid of the water at very low temperatures without, or it supposedly keeps most of the other organic phases that might be there. But it's just removing water. It's not necessarily removing other organic compounds, depending on the programming as well, right? There's modifications you can have. It's based on the freeze point of water. So you can customize that if you have other organic solvents in your matrix. And the good thing is for the most part, freeze dryers allow you to freeze dry a larger volume, right? Which is very important for us, for example, for wastewater. Depending on the freeze dryer size, there's so many customizations to the type of what's it called? The type of containers that you can have. It's also, you can have unlimited volumes, but it's typically used for a large volume concentration. And it also, quotation mark, guarantees you that you're only evaporating or removing the water. So we're just getting rid of the water, not necessarily the other organic phase compounds. In the other hand, nitrogen blowdown is designed for organic solvents. So nitrogen blowdown thrives in using an organic solvent versus freeze drying, it's more for water, right? And then it's also nitrogen blowdowns, it's also for smaller volumes typically. I don't know. I think there could be nitrogen blowdowns with larger volumes, but we typically use maybe, I think the craziest volume that we've ever tried of nitrogen blowdown, it's maybe 50 milliliters, but I don't think it goes beyond that. Versus in the freeze dryer, depending on the volume of your container and the capacity of your pump, because it relies on a pump to hyperfreeze or reduce the temperature very fast. That one, I think you can go up to 4 liters in one container, which is like a weird case. And ideally, you don't want to fill your container more than it should be half of the container capacity. So if I have a container of 1 liter, I should only be filling it up to half a liter, for example. But it's still half a liter, right? I don't need to. And I also don't want to be using nitrogen for that. Nitrogen could also be expensive depending on how you source your nitrogen. So it's either way, it's going to be expensive, but at least on one end, you can focus on water evaporation or water removal and large volumes. And then for the nitrogen blowdown, you focus on the organic phase removal and typically smaller volumes. And you have a lot to play with, right? Because again, PFAS has taught me a lot about PFAS. I don't know about the other molecules, but at least for PFAS, we assume that most of them are non-polar, or at least the longer chain ones. So we assume that most of them are going to be retained in the freeze dryer process. And then we go through a methanolic extraction procedure because we know that non-polar dissolves non-polar, and then we try to desorb as much as we can with this organic phase solvent. And then that's why nitrogen blow drying works, right?
Yeah, it's definitely two separate use cases, but I think that's a great summary for people out there who are learning about one or possibly both of those methods.
Yeah, I would say probably the nitrogen blowdown is also going to be cheaper than your freeze dryer. I think freeze drying, depending on what your applications are, typically freeze drying it's used for pharmaceutical manufacturing, but it's finding its ways into environmental testing because now we have a lot of complex matrices. And I think there's also an application, even talking from my biology side, helpful for preservation of other biological molecules like live cells, but we freeze dry them and then it's easier for sharing that enzyme or whatever. So it has a lot of applications beyond just concentrating. It also allows you to keep your whatever product more stable. But again, not as cheap. Nothing is cheap, but not as economically as efficient as nitrogen blow.